So this is our Zoom for February 20th. It's kind of acting as our test two Zoom just before test two. So as usual, it's just pretty much open forum. Any questions you want looked at, I can bring up Infinity. Anybody want to get us started?
Yeah, can I have you do a problem from the practice exam for me?
Sure. Is that the practice exam in Infinity?
Yes.
All right, let me go there. All right, which one do you want looked at?
It's number 37. It's the double integral over the triangular region with the vertices.
Sure. Let me scroll down to it. I'll share it here in a moment. Um, all right. Is it this one?
Um,
Because you know what, they might be there might be some randomization. Is it? Let me
it
scroll up. Go
it
ahead.
it quite literally says evaluate the double integral 10xy dA over the triangular region, and then it lists the vertices.
Okay, there's some randomization in how the.
It might be 29. I think it was 29 on the first. I'm going through another time. I think it was 29 on the.
Okay, there is some randomization. It's the same questions. Uh,
Yeah, I mean, I could just read it off to you. It's
yeah, why don't you do that? Just tell me what the particulars are.
okay. Just it says evaluate the double integral of 10xy dA, where D is the triangular region with the vertices 0, 0, 0, 1, and 0, or 0, 0, 1, 2, and 0, 3.
All right, so I'll stop the share. Um, Let me go to my other camera. So I'm going to change the window a little bit here. All right, I did something wrong. Hold on. There we go. So it's the double integral 10xy. The D is the region from 0, 0, 1, 2, and 0, 3, you said?
Yes.
All right, let's draw it, see what it looks like. There's 0, 0, 1, 2, and 0, 3. So it's going to be this rectangular region here. All right. Your main concern would be which order do you want to integrate? Do you want to integrate dy dx or dx dy? Did you have a preference?
Um, I don't have a preference. I
All
just
right.
go with whatever seems easier usually.
Well, yeah, that's what you should do. Yes. I was going to say that for if you do dy dx, you only have a single double integral. So if we do dy dx, just kind of lightly, I'm going to lightly draw an arrow in the y direction. What I need to do is I need to come up with some names for these boundaries. This line is going to be y. It's got a slope of 2, so it's just going to be y equals 2x. This guy over here, we're going to have to play with a little bit. It's got a slope of -1, and it's got an intercept of 3. Okay. This is the y-axis, but its name is actually x equals 0. So you need to come up with the names of the boundaries. So as a dy dx integral, your lower bound is the entry bound, which is 2x in this case. Your upper bound is the exit bound, which I'll write as 3 minus x. It's just a little neater. And then your outer bounds are always constant and you just simply look at the picture and look at where x roams. X goes from 0 to 1. And that would be your double integral for that particular problem in the dy dx ordering. If you do dx dy, you have a problem. I'll use my pen. If I just, the pen is going to enter the region on the y-axis, which is okay, but there's ambiguity as to where it exits. It either exits out of this line here or up here. And that means you're going to have to set up two double integrals. You'd have to set up one for the lower half and one for the upper half. And it'll work, but I think you'll agree that it's probably more efficient to just to work out a single double integral. So this particular ordering is probably the best.
I would agree. Thank you. That helps out a
Sure.
lot.
Was it the setup that you were mainly wondering about, or the actual working it out?
Oh, the setup, the working out isn't a problem. I
Okay.
was looking at it from I was doing it dx dy at first, and I'm like, something's not adding up here. And then looking at it that way, I'm like, oh yeah, I should have flipped and done dy dx, and then it makes a lot more sense.
If you do dx dy, I mean, if you really want to, you'd have to just simply rename these guys in terms of x. So this would be x equals y over 2. This would be x equals uh, 3 minus y, actually. And then you'd make a division right here, and you would set up one double integral for the bottom half and one for the upper part. All right. So if that's the case, if you're good with that, I'll leave it alone. You can take it from there.
Yeah, I'm all good. Thank you.
Sure. Does anybody else have any questions on this one? All right. So this was from the practice test, which is always a good idea to work out. As you probably figured out on the first test, it's a pretty good indicator of what to expect. Um, all right, so let's go ahead. Does anybody else have any questions they want looked at?
About like a particular question.
Uh-huh.
For polar coordinates, from doing the homework, it seems like it doesn't matter whether you do d theta dr or dr d theta first. Is that correct?
Most of the time it's correct because most of the time, if your region is truly circular or part of a circle, then the bounds will be constant. Um, in which case it doesn't matter the ordering. I tend to use drd theta simply because you have that extra r Jacobian, and usually it's just easier to take care of that first. And almost always you'll notice that you very rarely have theta as a variable. Or if you do, it's usually locked up inside a sine or cosine, which makes the calculations pretty easy. So generally speaking, it doesn't matter. The only exception, the only exception would be if you were doing an integral of one of those, like a cardioid, one of those regions you saw in Calc 2, where you have r as a function of theta. Um, but we don't really have too many of those in this class.
Okay, thank you.
So generally speaking, if they're constant bounds, you're good to go.
Yeah, so as long as you set up your bounds correctly, then that's kind of what I thought I noticed.
Right. Yeah. Ultimately, your success in double integration or any integration is make sure it's set up right. I mean, if you make an error in the setup, then everything you do afterwards is just wasted energy. All right. All right. Well, throw them at me. Got any other questions?
It's number 15. It says suppose z is equal to x squared sine y, and then it has x is equal to 4t squared minus s squared, and then y equals st. Said it's number 15.
Yeah. It's kind of frustrating that. Oh, I found it. Oh, I think I found it. Yeah. The numbers are randomized. I don't know or the problems are randomized. Is it this one? Mine is number 21.
Yes, that's it.
All right, good. All right, so let me copy the information. We have z is x squared sine y, where in turn x is 5s squared minus 5t squared, and y is negative 6st. Okay, what do we want to do here? We want to find the chain rules. We want to find derivative of z with respect to s and t, and then we want to evaluate at 3, 1. All right. A little trick I always use when I'm doing the chain rule at multivariables to imagine, set up like a tree diagram. You have two variables for the z function, they're x and y. And then x and y in turn each have two variables s and t. And the limbs of this tree get labeled with the partial derivatives. It just helps to see the structure of the derivative. Okay. So if I want to find dz ds, what I do is I start at z and I just go down the paths that end in s. So it's going to be this left path here. So it'll be dz dx times dx ds. And it's going to be this path over here, dz dy times dy ds. And since they're two separate paths, you add them. Similarly, d partial z partial t would just be paths that end in t. So it'd be dz dx dx dt plus dz dy dy dt. Really cosmetically the same except for the t's. So that's how you set up a chain rule, and then you can adapt this. You can have as many input variables as you want. You can have as many tiers as you want. I mean, once you see the pattern, then it's very easy to expand it, regardless of how many input variables and how many levels of composition you have. So in terms of this, I'll do this guy. I'll do this one with you, the partial z partial s. All right. So we just do partial z partial x, which will be the derivative here. It'll be 2x sine y times partial x partial s, which will be 10s, plus partial z partial y, that'll be x squared cos y, times partial y partial s, which is negative 6t. I'll pause here for a moment. Does that make sense?
Yes, it does. I wish I would have seen this tree chart sooner.
Yeah, it's a
If I
big
missed it
help.
in lectures, that's my fault.
That's all right. I have them in my notes too, so check there. As far as evaluation go, it's just plug and chug. S is 3, T is 1, but we have to also figure out what Y is. Let me do that. I'll do that in a moment. Here you just need to be careful of plugging in. So in both cases, we have a Y lurking. I made a mistake. Um, S is 3, not X. My bad. All right, I can fix that. Let's do that right now. Uh, when S is 3 and T is 1, I get 3 squared is 9, 45. Take away 5, that's 40. And when S is 3, T is 1, we get negative 18 for Y. All right, so I'll fix that. That should be a 40 for X. And then Y will be negative 18. And then this will be 40 again. You're going to get a crazy number here. And negative 18. Yeah, that looks good. All right, so I'm sorry about that. I messed up. I can clean up just a little bit. That's 30, that's 80. So we have 2400 sine negative 18. And then what do we have here? Negative 6. Oh, geez, 1600. So 1600 times 6, 9600 cos negative 18. Yeah, it's a weird number. All right. And when you do this, you always assume radians. So we're assuming that negative 18 is in radians. And you just work it out in your calculator. You know what? It should probably accept it in this form too.
I was going to say, if you leave it like that, it usually says it's the right answer.
Yeah. Yeah, you don't need to work it out. I mean, really, that's just kind of busy work at this point. The main important thing is that you get it set up right. Again, like if you don't set it up right, anything you do is just wasted energy. But yeah, understanding the structure to get the setup correct is critical. I'll tell you what, is that good enough for this one?
Yeah, you can leave it at that. Thank you.
Yeah, you guys can do the other one. Anybody else have any questions on this one? All right. I'll pause it here. And just feel free to jump in and ask any question you want. But this is one I like. Hold on, I forgot to share it. This guy right here, number 37. This one's kind of like a snake in the grass because it seems so like kind of simple. Let's take a look at this one. The integral is double integral e to the x squared dx dy. The x bounds are 6y and 6, and the y bounds are 0, 1. And you immediately run into a problem, and that is you can't integrate or antiderive e to the x squared dx. It's just simply, there's just no way to do it. Doesn't have a closed form. No form of substitution will work. It's just one of those weird functions that theoretically every continuous function has an antiderivative, but it may not be expressible in closed form. This is one of those cases. So in a case like this, your only option is to reverse the order of engineering of integration. Reverse the order of integration. And that means you need to figure out what shape this thing is. And a little hint that I give you is, especially on the inside integral, put a little x equals in front of the bounds. And sometimes that helps kind of jog the memory here. So now you're going to come and draw a picture. X equals 6 is going to be a line out here at 6. So I'll just sketch it in. X equals 6y is actually the same as y equals x over 6. It's actually going to be a line that has very gentle slope. In fact, if x is 6, that forces y to be 1. And so evidently this region is going to be this guy right here, because in the dx dy ordering, you're going left to right. You enter at 6y and you exit at 6. Okay. So what we're going to do, so this is the region. We've been able to infer the region from the picture, from the information. Now we're going to simply reverse the ordering. So whereas this was x equals 6y, it's also y equals x over 6. And whereas this guy, well, this is the x-axis, it's y equals 0. All right, so suddenly I look at it now as a dy integral going this way. My entry bound is 0. My exit bound is x over 6. And then my x bounds would be 0 to 6. And now I have an integral that will work because I can integrate e to the x squared with respect to y. It just means e to the x squared times y. But when you plug in x over 6, you get x over 6. I'll put it in front, e to the x squared. And then, of course, 0. Actually, 0 will just give you I'll just drop out. So y is 0 just drops out. All right, so I'll pause here for a moment. Does everybody catch why you want to do it this way?
It makes sense now that you've shown it that way,
Yeah.
but I think that was one of the problems that I kept getting tripped up on every time I just sat there and battled with it.
Yeah, you just can't do e to the x squared. If you are able to ever find an antiderivative for e to the x squared, you'll be famous. Although I think at this point it's been proven it can't be done. Um, from here on out, actually, it integrates really nicely because now I throw the integral symbol on there, bring the 1/6 to the outside. Now you can just integrate using Calc 1 techniques. Well, I need a 2x. I'll have to balance with 1/2. That should do the trick. And what do we get? 1/12 e to the x squared. And suddenly you get e to the 36 and then minus 1/2 e, just 1/2. There you go. So that's what your answer is. You're going to get a gigantic number out of that. If you type that in on your calculator, mine will probably choke on it. Let's see what happens. E to the 36. Yeah, it's 4.31 times 10 to the 15. All right. Well, that's just interesting. Yeah, the main thing is that recognize in this ordering you're stuck, but if you reverse the ordering, it works. All right.
Specific like test problem question. It's just a format.
Yep.
So like throughout the practice test, it will ask for like though sometimes there's like a random tangent plane question.
Yep.
And I don't know if format wise it wants me to start it as z equals or put in like the z sub 0 plus whatever blah, 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 equals 0. So I don't know how it wants me to format it because it will auto format later, but sometimes it's right and sometimes it's wrong. And I haven't been able to figure out consistently how it wants me to format the
And
equation.
you saw this in the practice test.
Yes.
Give me a moment here. I'm scrolling through.
There's like two different kinds of questions that involve the tangent plane. So hold on. I'm locked into one of my attempts right now. So I can't I have like 5 others. Right now I'm in one where it's number 20. There's one where it's like a surface, but you also put it in a vector. I think there's another one where it just asks for an equation of the tangent plane.
Yeah, I found one. Yeah. Yeah, of course, the ordering is a little different. Mine shows up on 26. Let me share the screen. Like this guy right here.
Right. When I'm gonna fill in that for the equation, should I format it z equals or should I format the equation and then equals either 0 or like a number?
Doesn't really say, so I would imagine it shouldn't matter as long as you make sure it's a valid equation. You know what? I'm going to cheat. I'm just going to click on it
Okay.
and see what the way they do it. It looks like they did it this way. It looks like they did it the spread out version. Can you see that?
Yes. Okay. So no z equals, just the equation itself, and then
Yeah, but I'm
because I've done
curious.
it where it's like I've typed in z equals and it says it's okay, but it auto formats it differently. I'm not sure. I couldn't find like a consistent. Thank you. That answers that.
Yeah, it appears that well, I always look at everybody's test anyway, and I always look at your wrong answers. So if it's a formatting issue, but you did it right, I would give you the points. Because I've seen people, some people will actually type a period at the end of their entry, which actually gets counted as wrong. I've had people do that. So little stuff like that. It doesn't appear to insist on a particular form, so it should accept any valid form. I mean, you could even push it and try setting it y equals, and see if it takes it.
Okay.
Yeah,
Okay, thank you.
sure. Are you okay? Are you comfortable working them out? I mean, you've got that skill down.
Oh, yes. I mean, knock on wood. Yeah.
And actually, it's interesting to note this one. They've actually isolated it in terms of x, and it makes no difference. Any one of the three variables can be the original output variable. Um, so it should make a difference. I would expect that it would accept any correct form as long as your entries are correct.
Okay.
Alrighty. Everybody comfortable with the second derivative test since I got it here? F sub xx times f sub yy minus f sub xy squared.
Yeah, the table given from the lectures was really helpful for those.
Okay. And you'll have access to Desmos. Some of these can be graphed, like when you're finding min and max. This one I've got highlighted right here is just a paraboloid. This one would be actually pretty easy to do. I think we did this one last week on the in the Zoom. This one right here. This one's an interesting one because it has three saddles and a max. It's a very bizarre surface, and it should be in one of the videos from last week. And then of course you got all your double integrals to worry about.
Can we work through that number 32? That's
This
another
one,
kind of fun one.
yeah. Let's take a whirl
Please.
with that one.
Yeah, please.
The nice thing about this one, let me copy it. All right. Well, it's got constant bounds, and that's going to make your calculation fairly easy. We're going to do a dy integral. So the 2 and the 6 are y values. We get what do we get? 1/2 y squared cos x minus 5y from 2 to 6. What do we get there? 6, 36, that's 18 cos x minus 30. And then minus, of course, you have to be careful with that. That would be a 2 cos x minus 10. You just want to make sure that you are careful with your parentheses. So collecting terms, we have 16 cos x, and we have negative 30 plus 10, so negative 20. And then that gets integrated with respect to x, which is here. All right, let me throw those on. So we have 0 to pi over 6, 16 cos x minus 20 dx. And yeah, make sure you memorize your antiderivatives from Calc 1. So sine of pi over 6, let's go ahead and plug it in. When I plug in 0, it drops them all out. Because sine of 0 is 0, and of course, x is 0 just drops that bar out. Sine of pi over 6, that is a number we know. That's 1/2. Is that right? Yeah. So sine of pi over 6 is just 1/2. And this one is just going to stay with the pi, so it's going to be 10 pi thirds. So the final answer is going to be 8 minus 10 pi thirds. Does that help with what you were doing?
Oh, yeah, yeah, yeah. Thank you.
Sure. All right. You just have to kind of deal with the algebra on 33 and 34. Again, stop me if you see one. Big skill is to reverse order of integration. This one we just did as a class. All right, what brings us to the end of
Professor,
it?
can I ask a question on the
Uh-huh.
setup for rectangular double integrals?
Yeah, sure.
So I guess my question is so when you set it up, you're going from, if you have dy dx, then you're going from the x-axis to and moving vertically up y. And then if you're doing dx dy, you're moving from the y-axis and moving to in the positive direction of x.
Right.
And so if you are on in different quadrants, would you just reverse the
No,
signs?
no, no, no. No. Always basically read it left to right or down to up. Um, so the quadrant makes no difference. For example, here I'll tell you what. Um, I mean, I could have a region back here in quadrant 3, for example, like that. But you would still, if you're going to do dx dy, you would go that way first, and then your y bounds would just be whatever these guys are. Make sense?
Okay.
If you're going to do y dx, you would go this way, then your x bounds would be whatever these guys are. So don't let
Gotcha.
the quadrants mess with you.
Thank you.
Sure. All right. No. Again, any questions? Are you okay? Are you doing okay with the min-max questions? I'm just looking through min-max. Here, let me share. Gradients, make sure you know that. Do we have any polar on this one? Did you guys see any polar on this question, on this practice test?
I think there might be one question, but it
Yeah,
doesn't come up every time.
most of these just look like kind of generic rectangular. That's interesting. I forget which section polar is in. Is it 12.3 or
I think it's 12.3, yeah.
yeah, I'm not seeing much of them.
Yeah, I think there's one question and it looks a lot like the one that I had posted in the Affinity.
Yeah.
It's that one. There it is.
All right, here, there you
Yep.
go. All right. That's kind of a shame we don't have more polar questions. Um, this one's just mainly, I think we did this one or something similar last week in the Zoom. Polar is ideal for any circular region or part thereof, anything that's composed of circles in some manner. This one looks like obviously like a D, right? Um, but if you draw your R radius from the origin outward, it'll enter the region at radius 1, and it'll exit the region at radius 3, so that your bounds will be 1 to 3 for R. The theta bounds on this guy right here, you want to make sure that you always sweep counterclockwise. You always want to go from a lower value to a higher value. So the higher value on the positive y-axis would be pi over 2 radians. That means that this guy down here at the lower part would have to be negative pi over 2 because you want to go from a lower value to a higher value. You know, if you type in 3 pi over 2 here, and you go from 3 pi over 2 to pi over 2, that actually takes you the other way around. And you don't want to do that. All right. I guess you'll see more polar on the third test. That's my assumption.
Quick
Polar is
question
really, go ahead.
with the sweep, like you said, but if the surface was on the other side, like mirror imaged,
Yeah,
you would be putting pi over 2 towards 3 pi over 2, right?
that is correct. Yes.
Because it would just always go that direction.
Right. You always want to go counterclockwise.
Okay.
And yes, you always, yes, in that case, if you were doing the quadrants 2 and 3, it would go from positive pi over 2, and then to the negative y-axis would be 3 pi over 2. That would be correct.
Now, if the third quadrant had a surface in it, and because you start from the origin on the right side, that line,
Uh-huh.
you would have to sweep back and then come back around. So what would your bounds end up becoming?
Like if I started on the negative x-axis,
Yes.
well, well, let me draw one.
Okay.
So let's say you had like a 3/4 of a ring. So yeah, because we always reckon off of the positive x-axis, so everything's kind of relative to here. And so the natural angle here would be pi over 2, 90 degrees. But yes, but if you want to integrate over this region, you're going to want to make sure that this thing is smaller than pi over 2. Normally, we'd call this pi, but that's going this way. To go backwards would be negative pi.
Got it. Okay. Thank you.
Then that allows you to sweep in the positive counterclockwise direction.
Cool. Thanks.
Sure. All right, we're down to the last 15 minutes. Any questions? Any others? Um, yeah,
I think the only ones I find difficult are I find them long. It's just
yeah,
all of the substitution questions, especially when you start getting sine and cosine mixed in with a substitution, or you've got
that
e
is
to the
true.
something mixed with cosines, and that they get to be, instead of doing them in a couple of minutes, they're quite lengthy. So I tend to just skip them till the very end.
Yeah, that's kind of the nature of, well, even in Calc 1 integrals, a lot of times the algebra could take multiple steps. There was one somebody posted it to Edfinity where, it was a very gentle looking integrand. I think it was just XY, but the algebra was intense.
Yeah, I
And,
recall which one you're talking about. Yeah.
and I just said, yeah, unfortunately, that's just comes with the territory. I mean, I can look at I have a number 33 and number 34 again, and from a mathematical standpoint, these are pretty mundane functions and regions. It's nothing exciting. But I tell you right now, it's going to take you probably 10 minutes to work them out because you got a lot of algebra, you got a lot of foiling and collecting terms and things like that. So that's just something you have to kind of bear with on these things. Really, unfortunately, there's not a shortcut for everything. All right. Again,
I'm
any last
assuming,
question? Go ahead.
sorry, I'm assuming that this test is formatted just like the last one, where there's a handful of multiple choice and a handful of work them out.
Yeah. Hold on. Um, Yep. Yep. Yeah, actually, again, yeah, this practice test is an excellent indicator of the real test. Well, are there any questions? All right. In that case, the test starts at 4 p.m. Mountain Standard Time. Make sure you know what your time difference is wherever you are in the world. And it'll run through tomorrow night, midnight Mountain Standard. And I'll do like I did last time. I'm just going to kind of I'll just keep a tab open monitoring things. So if you do get stuck on something between now and then, Ed Discussions is the place to put it. I'll have this video up, and again, probably about a half hour, 45 minutes. I'll alert everybody. So I wish you guys good luck and hope you all do well. I'll have grades figured out probably by Sunday night. So I'm going to go ahead and sign off. Thank you all.